number. Integral from -4 to 3 is like 4 minus 9 pi over 4, and this is, so, yeah, this is h. So in fact, Emma is sort of citing the fact that these two accumulator functions must differ by a constant because they have the same derivative, and we have theory that tells us that. But Kendall is actually like just telling us specifically the constant by which they differ by. And the constant by which they differ is just whatever the integral from -4 to 3 is. Is this kind of like making all sense? Right? So yeah, yes, these two functions differ by a constant. If you start integrating at a different place, then the difference between this function, which starts integrating at 3, and this function, which starts integrating at -4, the difference between those two functions at any given point is just whatever the integral is from -4 to 3, right? That's how much you're off by. Follow? Okay, and that is why when we talk about the real FTC and we talk about the derivative of the integral from a to x, sometimes weirds some people out that I just write a here, right? I just write a here because it is irrelevant where I start integrating from, because all these integrals are really just the same. They all just differ by a constant. And this is answering the question, what is the instantaneous rate of change? And so if I want to know what's happening at x, it's irrelevant like where I started, because starting at different places is just going to change the accumulator function by some constant. Okay, so that was like a thing. That was like a thing to talk about. So, racing vectors and baby talk, science sharps. Okay, good. We had some homework. Let's talk about the homework. Some of it was hard, I thought.
So good.
Go.
The other comments are not saying not to go. No, not to get out the other one.
Okay, so let's do just some of these problems. It was page 327. Do you have some like ones you want to go over? I have some ones I want to go over.
109.
Let's do 15. Let's do 23, 35, 51, 89, 109. How do we feel about that? Yeah, that's good. That's all I have time for anyway. What is 109? Oh yeah. Yeah. Yeah, that's what we're gonna do. What's 89? Oh yeah. Okay. Okay. Let's do a bunch of these right now. And you're back up here, Bobby? Yeah. Could someone Eober or somebody could erase the front board? That'd be awesome. All right, number 15. It is pretty hot here. Catch me, you okay? Yeah. Yeah. All right. So this is the integral from 1 to 4 of u minus 2 over root u du. Okay. How should we do this? Split it up. Yeah. The first thing you should think is, man, I have an integral I have to do. If only I knew an antiderivative. So really this just becomes an anti-differentiation problem. And Raymond says, yo, I know how to do this. I'm going to split this up. So if we split this up, we get root u minus 2 over root u. Why is that a good idea to split up? Because now it's like easy to anti-differentiate, right? So really this is the antiderivative from 1 to 4 of u to the 1/2 minus 2u to the -1/2. And notice how I'm like being nice and neat and careful and writing my integrand in a nice anti-differentiation friendly form. Okay, now we just do the anti-differentiation. So when we integrate u to the 1/2, we get like 2/3, did I mess up? You're looking at me crazy.
No, that's right.
Okay, cool. 2/3 u to the 3/2. What's wrong? Question?
I don't know.
Good. Minus, and then that goes up a half to be 1/2, but then 1 over that is 2, so it's like -4, right? U to the 1/2. Yeah. And then all of this is being evaluated at 4 and 1. So again, I think this is like the neat way of doing it. Okay, and now I plug in, I'm gonna evaluate the expression 2/3. If I plug in 4, I get that's times 8 minus 4 times the square root of 4 is 2 minus whatever I get when I plug in 1, which is 2/3 minus 4. And I don't know, I just get like a bunch of crap basically, right? I get 16/3 minus 2/3 minus 8 plus 4. That is 14/3 minus 4. So, did you get 2/3 in the end? Okay, can you guys all handle this? It's like a multi-step problem. It sort of assumes that you're an expert on differentiation. All right, Rohan, you good? Okay, how about 23? Rohan, what'd you do for 23? This is the integral from 0 to 3 of absolute value 2x minus 3 dx. What now? What?
I split it up.
What are you doing over there?
What?
What's all this? Like Spanish or something?
Yes.
Saltar el rey. Okay, good. You split it up? Did you draw a picture?
No, I just split it up.
You just split it up?
Terrible.
Okay, explain, continue.
No, draw a picture.
So I split the integral between 0 and 3 over 2 of 3 minus 2x plus the integral
I have to go to the 0.
3 of 2x minus 3x.
Yeah, so okay, maybe we should just quickly graph this, just so we have some sense of what's going on. Yeah, Rohan, I plug in 0, I get 3, right? And if I plug in 3, I also get 3, but like this is like a line, it must be just like this, right? It's like this is the function? Yeah. So one way to do this, and no shame, is just draw a picture and then just look at it and just like, yo, what's the answer? I think it's just 3 times 3 halves. I think it's just 9 halves. Yeah. Pretend if you did it that way. That's kind of like how we practiced before we knew the FTC. But Rohan said we could also do it. Rohan, how do we handle absolute values in calculus? By splitting it up and like getting rid of them, yeah. So he says, yo, can I just write this as the integral from 0 to 3 halves of absolute value 2x minus 3 dx plus the integral from 3 halves to 3 of absolute value 2x minus 3 dx. And then just like observe what is 2x minus 3 on the interval from 0 to 3 halves? It's like negative, right? You guys with me? Yeah, this is negative here, so thus what I really need to do is I need to integrate like from 0 to 3 halves of negative 2x plus 3. You did all this, Ron? You like split it up like that?
Yeah.
Yeah, and then the integral from 3 halves to 3 of, now using the definition of absolute value, 2x minus 3, the inside is positive on the interval from 3 halves to 3, thus here I just leave it, whereas here I put a negative up front. And then you could just do this, right? I mean, you should get like, what is that, like negative x squared plus 3x evaluated at 3 halves and 0. And here I should get x squared minus 3x evaluated at 3 and 3 halves. If you just do all this out, I don't feel like it right now. Do you get 9 halves? Yeah. Okay, so this is how you can deal with the integral of an absolute value function by splitting it up into the sections on which it's positive and negative and treating them separately. Or you can just draw a picture, which turns out to be really nice. Alright, going faster, I feel like I'm boring some people. 35. Do we need to do 35?
Nah. Can we do like...
Okay, good.
No, what did you guys give the
51? Oh yeah, 51 is just a cruel problem that turns out terrible. So we're just all gonna now just like suffer together. I feel like that's how people become friends, right? But don't when you just team up against a common enemy, but I'm not the enemy. This problem said find the value of C guaranteed by the mean value theorem for integrals for this function over the given interval. All right, try to draw this. I might like fail. How do I sketch this function?
Well, that was really obscure one that had like.
Let's see, yeah, pull out a root x, and then it would be like root x minus 2, right? Yeah. So, if I graph this, there's going to be a root at 0 and a root at 4. And someone told me that the minimum is at 1. Something like that. So there's 2. And I guess I only care about the average value on the interval from 0 to 2, right? Okay. So here's kind of like a picture. And so this is the function on the interval from 0 to 2. And we want to know what the average value of this function is. I think it might be even more like, I don't know. So what is the average value? Well, the average value on the interval 0 to 2 is like the place where, I feel like it's like that or something, right? It's the y value such that this area and this area is the same as this area. And everything's negative, so it's like upside down mountain. Okay, so how do we find the average value? That's like step 1, just find the average value. So the average value of f on the interval 0, 2 just is, well, it's the integral divided by the width of the interval, right? So it's 1/2 times the integral from 0 to 2 of x minus 2x to the 1/2. And so now with the FTC, doing integrals is suddenly like really easy. I can just do this. And so what I'm going to get is 1/2 times, what is this? This is like x squared over 2 minus 4/3 x to the 3/2. Did I do that right?
Yeah.
Yeah. And when I plug in 2, I'm going to get 1/2 times 2 minus, and then that's like root 8. Yeah, 2 root 2. So this is like, this is like 8 root 2 over 3. Is that what you got? Yeah. So my answer is 1 minus 4 root 2 over 3. All right, and I wish I could just stop there. I wish it just asked me for the average value. If it asked me for the average value, that would be my answer. That is the average value of this function. It's the integral divided by the width of the interval. But what they actually wanted was to demonstrate the mean value theorem for integrals by finding the c such that, so they wanted to know what is the x value at which the function obtains its average value. So that just sets up a disgusting algebra problem. And how did you guys do this? Did you just give up or use a calculator, or what did you do?
We cried and gave up.
I didn't realize you had to calculate.
Okay, yes, CalChat just like gives decimals, so I think they just said, right? Or no, they did it. Okay, that's a trick question to see if you, all right.
And yes, we do.
Where would you put the stolen nuclear secrets, like, if you had them? Okay, so, yeah, here, I think, can we just like, what?
I don't know, just like,
Yeah, you can just like complete the square, yeah. I think that's what we do, right? We add 1 to both sides, then this is like, I just get this gross mess, and then this is now like x minus root x, root x minus 1, right? Did I do that right? Yeah. Equals 2 minus 4 root 2 over 3. And now, like, take the square root of both sides or something? Oh, and now this is like plus or minus root 2. So, I mean, at this point, I'm like, I don't even care anymore. So I get root x is going to be like 1 plus or minus root 2 minus 4 root 2 over 3. And now I have to square both sides. So the final answer is that x is the square of 1 plus or minus root 2 minus 4 root 2 over 3. And I think I had some vague memory from like last year or whatever that actually both of those turn out to be valid. That if you type those into a calculator, they are both on the interval 0, 2, which means I cheated by sort of making my picture correct in advance because I knew it turned out this way. But what that means is that there are 2 places on the interval from 0 to 2 at which the function obtains its average value. Are you guys basically with me? Okay. Gotta remember to not sign that problem anymore. Let's do 89, and what is 89? Oh, this is a weird problem. It's kind of silly. Also, this problem a little bit. 89 says they define some big function f to be the integral from 8 to x of the cube root of t dt. And now they say that what they want you to do is first integrate the function and then differentiate. Just like because like we can or something, or we might feel like doing that. So what is this function? Well, we can just do this using the useful FTC, right? The useful FTC says that this will be this is like the integral from 8 to x of t to the 1/3, and so it's like, what is that? Yeah, so it's like 3/4 t to the 4/3 evaluated at x and 8. So it turns out that f is really.
Can you please write the other bracket?
I never read the other bracket. It's like a thing.
Wait,
no,
you did right over there. Look.
Is that just me or it's
Look,
like
Mr. Rose.
I don't understand when you
Right
need
there.
You sometimes never read the other bracket.
Okay, so,
Pisses me off. Like,
whoa. Okay, and then like minus, and then like, what is that, 216, that's like 12?
Yeah.
Did I do that right? Yeah. Okay, so this function is actually just 3/4 x to the 4/3, like minus 9. Yeah. And then it says, in a sort of silly move, yo, differentiate that, just like see what happens. What happens?
It's exact.
Yeah, we get x to the 1/3. Thus, sort of just like showing, I don't know. I think that's what they wanted to do, right?
wait, wouldn't it be 12?
Yeah,
16?
yeah,
It'd be 16.
Did something wrong?
Yeah,
3/4
instead of
times
12, it
12?
would be 16, then it'd be, and then it's 12.
You did it like this, and
Yeah.
then did it again.
Wait, I made a mistake or I didn't?
Yeah,
You did.
don't multiply by, it should be 16, not 12.
did like
This is 16.
Wait, so that should be, just like, that should just be like 16. Oh, yeah, and then that's 12, like that?
Yes.
Now is it right?
Emma.
Okay, good. So then, anyway, that's the thing. All right. There's one more problem I want to talk about, which is 109. Does anyone want to talk about anything else besides 109 from this homework?
Nah.
Was the homework okay, basically? Pretty chill-ish? Okay. All right, so 109 is a serious problem. It's almost like, if there was like the whole course of calculus all built into just like one problem. Yeah.
This is the worst problem.
It is the classic calculus problem. I actually think the way the book does it is like, what they tell you to do is like a little bit weird. They don't explain why. So we are now going to understand all things. Here is what the problem says. Consider a particle moving along the x-axis where x of t is the position of the particle at time t, x prime of t is its velocity, and the integral from a to b of the absolute value of the derivative of the position is the distance the particle travels. And then they give you some position function. Okay. So here is the position functions. T cubed minus 6t squared plus 9t minus 2. And what we want to know is, the goal is find the total distance traveled. So we want to find total distance traveled on the interval 0, 5. All right. So we're gonna solve this problem, and we're gonna solve a couple other problems also. And we're gonna do this the sort of intuitive way that involves. Well, we're gonna do this a whole bunch of different ways. We're gonna do it the books way, we're gonna do it other ways. Okay, first of all, suppose you cool? You're just like. Okay. First of all, what is the displacement? What is the displacement on the interval 0, 5? By the way, if you're not super comfortable with that word, the displacement is just the change in position. This is synonym. So the displacement. So here we have. This is like our old friend, right? Particle moving along a line. And now what we want to find the distance traveled, but also the displacement. So the displacement is actually the easiest one, right? This is just the change in position. In other words, Megan?
X of 5 minus X of 0.
Yeah, this is just x of 5 minus x of 0. And I guess we could even just do that, right? Let's see, what is x of 5? 125 minus 150 is negative 25, and 45 is 20. Is that 18? Someone double check that. And then minus x of 0, which is negative 2. And so the answer is 20. Okay. So that's an interesting question to ask. Note that that is not the question that they are asking, but it is an interesting question. And so if we want to sort of draw a number line here and think about what's happening, let's see, where am I at? So this is I don't even know what I'm doing. I guess this is 0. And then let's see, where did we say, where am I at time 0? At time 0, I'm at negative 2. So here's my position at time t equals 0. And then later on, at time, number line not to scale, later on at time 5, I'll be here at 18. And thus, on the interval from 0 to 5, my overall change in position was 20. Okay, but that doesn't really capture the true story, because I'm like moving, this is a cubic, so it probably like does cubic things, right? It probably just like goes back and forth and stuff. And so the total distance traveled is going to be greater than the total displacement. Is everyone cool with that? Give him a couple kicks in the, whatever. First leg, later on, face. Hey, careful, get up and erase it backward. Good. Okay. La 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 la. I was gonna do something. Oh yeah. Good. By the way, is there another way that we? Okay, so I guess that's good. One thing we might want to do. How can we tell when, using our knowledge from like March, how can we tell when this function starts like turning around and stuff?
When it's 0.
Yeah, we can take the derivative, right? The derivative is going to tell us when the function is moving to the right and when the function is moving to the left. So somehow it seems like unavoidable that we will take the derivative of this position function. So x prime of t, which I'll just call v of t, the velocity, is going to be, well, okay, let's do the derivative. So this is like 3t squared minus 12t plus 9. Okay, and now what seems like a good idea if we would like to know when the function is moving to the left and when the function is moving to the right?
See when it's 0.
So like, do some math, right? Factor this. I think you kind of almost like had to do this anyway to do this problem, unless you use a calculator. So we factor out 3 is t squared minus 4t plus 3, and that factors nice and beautifully 3 t minus 1, t minus 3. All right, I now feel I have a sense of this problem. This is my velocity. Maybe I should even make a sign chart for velocity. And I'm just going to start at 0 and I'm going to end at 5. So what should the sign chart for velocity look like? That's 0, that's 5, that's 1, and that's 3. And then what's the sign distribution? Everyone, not just you? Yeah. Okay, I'm now getting really smart. I feel like I know what's up. At time 0, I'm at position -2. according to this is my position function, I've differentiated the position function to get a velocity, and now according to an analysis of my velocity curve, my velocity is positive on the interval from 0 to 1, which means I'm moving to the right on the interval from 0 to 1. And then when I get to time 1, my velocity becomes negative, which means I start turning around, right, backtracking. And then I keep moving to the left until I hit time t equals 3, at which point I turn around and start moving to the right again. All right, so indeed my total distance traveled is going to be greater than my velocity. Okay, how could I figure out the total distance traveled then? You add them up on those intervals. You add them up on those intervals. In fact, perhaps the best thing to do to truly understand this is to make a graph of velocity. And this brings it back to the whole problem which inspired the fundamental theorem of calculus to begin with. But now we're getting serious because previously we just drew a bunch of like always positive velocity functions, or we often did. But now we have to take negative velocity seriously, and we're trained to do that. So I don't know. Let's make a graph of velocity. Where am I at time 0 for velocity? What's my velocity at 0? 9, he said. Is he right?
Yes.
I feel like he is, yeah. And then I've now learned at time 1, my velocity is 0. And at time 3, my velocity is also 0. What is my velocity at time 5?
Also 0.
No, I don't think so.
Non-existent.
Non-existent. What is my velocity at time 5?
24.
If we plug in 5, we get 3 times 4 times 2. 3 times 4 times 2, 24. Yeah. Okay, so picture not total. Actually, it's pretty good. So here is a picture. I mean, if you understand this problem, you pretty much get all of calculus. Everything else is just unimportant crap. All right. Ravi Fleischman, here is my velocity curve, which I got by differentiating the position curve and then just like being smart about like knowing things about polynomials and stuff. Okay, so now think back to what we did way long time ago when we cared about finding the area under the curve. What does the area under the curve? What is the integral from what is the area of the curve from 0 to 1? What does that represent? Yeah, it's sort of, I guess there's a bunch of different answers, but it's like the distance traveled on the interval from 0 to 1, right? And then what about the area between 1 and 3? Well, that is, if we're treating it as a positive for the moment, that's going to be the distance traveled on the interval from 1 to 3, and then if I do this, that's going to be that distance traveled. Okay, so now the book, notice that the book mentioned something about the absolute value of the velocity, but what is the absolute value of the velocity, of course? Yeah, that's just the speed. And it's in the following sense that taking the, so if what I'm now going to draw is the speed function. What is the speed function? The speed function is just the absolute value of the velocity function. So it looks just like the velocity function until here, but then it just does a little up business. Then it goes up here. And so if you recall in the book, they say something like take the integral of the absolute value of the derivative of the position. What they're really saying to do is take the integral under the speed function. And the integral under the speed function will be the total distance traveled. But it's also possible to do this not even really kind of almost knowing anything about integrals at all. Because what is the distance traveled on the interval from 0 to 1? Well, it's going to be where I am at 1 minus where I am at 0. Are you with me? That is the displacement on the interval 0, 1. That's going to be a positive number because I know I'm moving to the right on that interval. And now I want to take this guy. Well, that's going to be where I am at 3 minus where I am at 1. But I'm moving to the left on the interval from 1 to 3. So if I'm moving on the left from the interval from 1 to 3, that number is going to be smaller than that number. Follow? So I need to subtract this change in position because I know that this quantity is going to be negative because this guy is going to be smaller than that guy because the velocity is negative. And then finally, I add x of 5 minus, maybe I'm making too big a deal of it. I don't know, I think this is a D problem. So I get this expression. But of course I could also do this with an integral, right? If I did this with an integral, what I would do is I would take the integral from 0 to 1. The book said to do to take the integral of the derivative of the position function. But of course the integral of the derivative of the position function just is x1 minus x0, right? And then it said to add to it, it actually said absolute value, but in this case it's positive. And then it said to do the integral from 1 to 3 of the absolute value of the speed plus the integral from 3 to 5 of the absolute value of the derivative of the position. So if you sort of think about what's going on here, each of those is that thing, right? Is this making sense? I feel like it's a good problem. Okay, so there is this difference between distance and displacement. The integral from 0 to 5 of the velocity is going to give you the displacement. The displacement on 0, 5. If I want to know the total distance traveled, then I need to take the integral from 0 to 5 of the speed. In other words, of the absolute value. This is going to give me the true distance traveled. Distance traveled on the interval 0, 5. But, oh my god.
What? Is that possible?
Of course, in practice, without a calculator, if I wanted to actually do this integral, well, how would I have to do it? Splitting it up. Do it faster? I'd have to do it faster. All right, good. Can I have all of this homework? Let's put it right here, next to Danya. Okay, 5 more things.
5 more.
This seems impossible.
Yo, 5 more things.
Always seems impossible.
Wait, when were you last in period 3 math class? When were you last in period 3 math class? When did you last have period 3 math? It's like the end of this semester. I'm sorry.
Wow, you ogre. How could you? That's just an ogreish thing to do.
Yeah.
Yo, period 3 is gonna have to listen to
Okay, sorry. Request to go faster. Good, will do. All right, what I would like to do now is, so we know how to do differentiation, right? What I now want to do is integration with
be on the camera,
substitution. Okay, so suppose that my goal is I want to find the integral from pi over 4 to pi over 2 of 2 cosine 2x dx. All right, there are basically 2 ways to do this. There's like one sort of lame way, and then there's like a good way. The lame way, which experience has told me that you all want to do.
Yeah.
But I'll try to convince you not to. The lame way is to say, look, I know the FTC. I am going to just